journey into the future of space exploration. In this episode of Astral Adventure, we dive into NASA's ambitious future projects, focusing on the accelerated plan for the moon and beyond. We look at how Artemis II paves the way for a long-term lunar presence, and how these technology will fuel the journey to Mars. From the nuclear power spacecraft to the construction of a permanent moon base, witness the next great gap, a great leap for humanity. And so once again, I'd like to welcome you all back to another episode of Astral Adventure. We have put together this little small presentation for you to enjoy. The NASA mission Artemis II missions to the moon, Lunar, and beyond. The mission to the moon, to Lunar, is just a preparation for actually the mission to Mars and beyond. In order to get to Mars, we have to get to the moon first, then thereby launching a mission on to Mars. It would be impossible to launch a mission from the Earth to Mars, simply because we can get there, but we will not be able to get back. It's like going on a long trip to California and you have no gas station, no rest areas or fuel stops to refuel, and so you have to have these things in place because of the length of the journey. Other than that, you are simply on a one-way trip, and that one-way trip will have to be a suicidal trip, simply because you would not be able to get back to Earth. So sit back, relax, enjoy this presentation that we have put together, including the launching Artemis II to the moon and the astronauts returning back to Earth. So relax, enjoy. Don't forget to like, share, and subscribe. Feel free to leave a comment below. Thank you in advance for watching, and we'll see you in the next episode.
The year was 2026, and the lunar horizon wasn't just a silhouette of craters anymore. It was a construction site. On the edge of the Shackleton crater, where the sun almost never sets, a flicker of artificial light signaled the beginning of Artemis Base Camp. Commander Elias Thorne looked through the reinforced glass of the Orion capsule. Below him, the Lunar Terrain Vehicle, LTV, a sleek, open cockpit rover, was being remotely guided across the regolith. Its mission was simple but vital: scout the permanent darkness zones where ice lay hidden, waiting to be turned into rocket fuel and oxygen. Astral Control, this is Artemis II, Elias radioed back to Earth. The base is breathing. I repeat, the base is breathing. The breath was the lunar oxygen LO2 pilot plant, a $20 billion marvel of engineering that was currently extracting the first breathable air from moon dust. This wasn't just a short visit like the Apollo missions of the 60s. This was the foundation of a new home. By the end of 2026, the plan was clear. The moon had become the ultimate gas station in the stars, with the lower gravity making launches easier. The nuclear-powered engines for the Mars transfer vehicle were already being tested in orbit. As Elias watched the Earth rise, a blue marble hanging fragile in the black, he knew the moon was no longer the destination. It was the doorway. The next footprint wouldn't be in gray dust. It would be in the red sands of Mars. In April 2026, NASA is moving beyond the shakedown flights and actively laying the groundwork for a permanent lunar presence. Here is the real-world science behind the tech mentioned in the story: lunar oxygen, LO2 extraction. Instead of hauling heavy tanks from Earth, NASA is developing in situ resource utilization, ISRU, to live off the land. Carbothermal reactors, systems developed by partners like Sierra Space, use high-powered lasers to heat lunar soil, regolith, to extreme temperatures. This chemical reaction strips oxygen from minerals like ilmenite. Molten regolith electrolysis, galore. This method melts the soil entirely and passes an electrical current through it to bubble out pure oxygen. The pipeline. NASA is even researching a lunar South Pole oxygen pipeline to transport this gas from extraction plants to the main habitat. Lunar Terrain Vehicle, LTV. The new LTV is a hybrid rover. It works like a crewed car and a robotic Mars explorer. Dual mode operation. It can be driven by astronauts in suits or operated remotely from Earth to move cargo between landing sites. Extreme durability. Unlike the Apollo rovers, these are built to survive the 14-day lunar night, where temperatures drop to 280 Darrow. The fleet. NASA has awarded contracts to teams like Intuitive Machines, Lunar Outpost, and Venturi Astrolab to provide these rovers as a service. Artemis Base Camp NASA recently announced a $20 billion plan to build a permanent outpost over the next 7 years. Strategic location. The base is targeted for the lunar South Pole, specifically near craters like Shackleton. These areas have peaks of eternal light for constant solar power and permanently shadowed regions containing water ice. Nuclear surface power. To survive the long nights when solar isn't available, NASA is developing small portable nuclear fission reactors to provide reliable electricity. Phased growth. The plan includes a fixed foundation surface habitat for 4 people, a pressurized rover like a mobile motorhome, and advanced communication towers to create a lunar GPS spaceflight now. The transition from Apollo to Artemis marks a shift from flags and footprints to a permanent presence. As of April 2026, the Artemis II crew has surpassed the distance record for humans in space, reaching 252,799 miles from Earth, about 4,000 miles farther than the record set by the ill-fated Apollo 13. Feature Apollo Program 1961-1972, Artemis Program 2026+, Mission Goal Cold War, Space Race, Prove landing was possible. Sustainable habitation, establishing a lunar economy, and gateway to Mars. Crew diversity, exclusively white male test pilots. Diverse crews including the first woman, first person of color, and international partners. Launch vehicle Saturn V 363 FT tall, 7.6M LBS thrust. SLS 322 FT tall, 8.8M LBS thrust, the most powerful ever. Computing analog systems, 4KB memory, sextant navigation, digital avionics, 128,000x more memory, GPS and high bandwidth video, duration short stays, max surface time, 75 hours on Apollo 17, long-term stays, planned surface time of nearly a week for early landings, resource plan, pack everything, all supplies brought from Earth, live off the land, using ISU to extract oxygen and water ice from the moon. Spacesuits, 1 bulky suit for both launch and moonwalks. 2 distinct suits, custom launch Dutch re-entry suits and flexible Axiom space moonwalking suits. Cost $290 by in modern dollars, funded like a race. 105B projected for first landing, leveraging commercial partners. Recent milestones, April 2026, safety priority. Unlike Apollo 8, which orbited the moon 10 times, the current Artemis II mission is using a free return trajectory, a slingshot, to fly behind the moon and return home safely without a lunar orbit engine burn. Distance record. In the first week of April, the Orion spacecraft broke the all-time human distance record while capturing high-definition footage of the lunar far side. International power. While Apollo was a strictly national achievement, Artemis is a global effort guided by the Artemis Accords, with Canada's Jeremy Hansen currently aboard Artemis II as the first non-American on a lunar mission. NASA's strategy for the Mars Transfer Vehicle, the spacecraft that will carry humans to the Red Planet, is currently being flight tested through the Artemis missions. Instead of building the Mars ship all at once, NASA is testing its critical systems in the harsh environment around the Moon right now in 2026. 1. Nuclear propulsion, the engine of the future. To get to Mars in months rather than years, NASA is pivoting toward nuclear-powered engines. Space Reactor 1, SR-1. Freedom. NASA recently announced plans for the first ever nuclear-powered interplanetary spacecraft, targeted for a 2028 mission to Mars. Nuclear electric propulsion, NEP.
Earth's gravity keeps the moon in orbit, while artificial satellites revolve around Earth to monitor, communicate, and explore our planet. Earth's gravity keeps the moon in orbit, while artificial satellites revolve around Earth to monitor, communicate, and explore our planet. Earth's gravity keeps the moon in orbit, while artificial satellites revolve around Earth to monitor, communicate, and explore our planet. Earth's gravity keeps the moon in orbit, while artificial satellites revolve around Earth to monitor, communicate, and explore our planet. Earth's gravity keeps the moon in orbit, while artificial satellites revolve around Earth to monitor, communicate, and explore our planet. Earth's gravity keeps the moon in orbit, while artificial satellites revolve around Earth to monitor, communicate, and explore our planet. Earth's gravity keeps the moon in orbit, while artificial satellites revolve around Earth to monitor, communicate, and explore our planet. Earth's gravity keeps the moon in orbit, while artificial satellites revolve around Earth to monitor, communicate, and explore our planet. Earth's gravity keeps the moon in orbit, while artificial satellites revolve around Earth to monitor, communicate, and explore our planet. Earth's gravity keeps the moon in orbit, while artificial satellites revolve around Earth to monitor, communicate, and explore our planet. Earth's gravity keeps the moon in orbit, while artificial satellites revolve around Earth to monitor, communicate, and explore our planet. Earth's gravity keeps the moon in orbit, while artificial satellites revolve around Earth to monitor, communicate, and explore our planet. Earth's gravity keeps the moon in orbit, while artificial satellites revolve around Earth to monitor, communicate, and explore our planet. Earth's gravity keeps the moon in orbit, while artificial satellites revolve around Earth to monitor, communicate, and explore our planet. Earth's gravity keeps the moon in orbit, while artificial satellites revolve around Earth to monitor, communicate, and explore our planet. Earth's gravity keeps the moon in orbit, while artificial satellites revolve around Earth to monitor, communicate, and explore our planet.
NASA is currently executing an overhauled roadmap that prioritizes establishing a permanent moon base before launching human missions to Mars. Artemis and lunar exploration. The focus has shifted from the orbiting Gateway Station to building Artemis Base Camp directly on the lunar surface. American Nuclear Society, ANS American Nuclear Society, ANS Artemis II, completed April 11, 2026. This historic 10-day flyby took 4 astronauts 252,799 miles from Earth, the farthest any human has ever traveled. Artemis III, mid-2027. This mission will be a low Earth orbit demonstration to test the Human Landing System, HLS, developed by SpaceX and Blue Origin. Artemis IV, early 2028. Targeted as the first crewed lunar landing since 1972. Artemis V, late 2028. This mission will officially begin the construction of the permanent lunar base, utilizing advanced power systems, Mars and nuclear projects, following the cancellation of the flagship Mars sample return program in early 2026. NASA is pivoting toward high-efficiency transit technology. Space Reactor 1, SR-1. Freedom, planned for a December 2028 launch. This will be the world's first nuclear electric interplanetary spacecraft. It will deliver the Skyfall payload, a trio of advanced helicopters, to scout Martian landing sites and subsurface water ice. Escapade, November 2026. Twin NASA spacecraft will perform a gravity assist at Earth before heading to Mars to study how solar wind interacts with the Martian atmosphere. Future human presence, with commercial partners like SpaceX delaying their independent Mars goals into the 2030s. NASA is using the moon as a proving ground for the long-duration life support and nuclear power needed for the first human Mars missions in the mid-2030s. Deep Space and Astrophysics Dragonfly, July 2028. NASA's car-sized nuclear-powered rotorcraft is currently in the integration phase, preparing to fly across Saturn's moon Titan to study prebiotic chemistry. Nancy Grace Roman Space Telescope, late 2026. Slated for launch as early as September, this flagship observatory will survey billions of galaxies to study dark energy and search for exoplanets. Europa Clipper, December 2026. This mission will perform a critical gravity assist at Earth on its multi-year journey to determine if Jupiter's moon Europa could support life. The Skyfall mission, recently announced for a December 2028 launch, will carry a payload of 3 to 6 Ingenuity-class helicopters to Mars. Unlike their predecessor, these rotorcraft are fully equipped scientific scouts designed to map resources for future human arrivals. Scientific Instrument Suite. Each helicopter in the Skyfall fleet will carry specialized sensors to perform high-speed reconnaissance that ground rovers cannot achieve. Ground Penetrating Radar, GPR. This is the mission's killer app. The GPR units will map subsurface water ice, characterizing its size, depth, and purity to determine if it can be mined for future astronaut crews. High-resolution multispectral cameras. These cameras will scout potential landing zones, identifying hazardous slopes and boulders that could endanger human-scale landers. Atmospheric sensors. These instruments will collect data on wind patterns and dust density within the Martian atmosphere, which is critical for refining entry and descent models for heavier human craft. Integrated radio relays. To solve the communication gap, at least one helicopter may be dedicated to acting as a high-bandwidth relay station, beaming data from the others directly to Mars orbiters for transmission back to Earth. The Skyfall maneuver. A major breakthrough of this project is its deployment method. Instead of requiring a multi-billion-dollar landing platform, the helicopters will use a mid-air release. Atmospheric ejection. The entry capsule will release the helicopters while still descending through the atmosphere. Autonomous spin-up. The helicopter's rotors will spin up immediately after ejection, allowing each vehicle to fly itself down to a controlled landing at pre-designated scout zone. Future missions context. Post-2028. The Skyfall project is just the first step in a broader strategy for the 2030s industrial foundation. The mission will establish the first regulatory and safety precedents for launching nuclear electric propulsion (NEP) systems like the SR-1 Freedom. Subsurface scouting. If Skyfall identifies significant ice deposits, NASA plans to follow up with robotic ice miners in the early 2030s to test extraction technology before humans arrive. Long-range recon. Data from these helicopters will help mission planners select the final site for the first human Mars habitat, ensuring it is located within walking distance of vital water resources. The Skyfall mission, December 2028, targets specific regions where scientific curiosity meets survival necessity. The primary objective is to scout the northern mid-latitudes, where a thicker atmosphere aids landing and subsurface ice is most accessible. Primary scouting targets for Skyfall 2028-2029, the helicopter fleet will likely prioritize areas within the 25 degree to 40 degrees northern latitude belt. Amazonas Planitia, recently identified as a perfect spot, this region offers a rare balance of consistent sunlight and shallow ice deposits, less than 1 meter deep. Arcadia Planitia, a top candidate due to its vast, flat terrain, frequently described as an ice-rich parking lot ideal for large human-scale landers. Noctis Labyrinthus, Eastern Edge. The helicopters may scout this rugged interface between Valles Marineris and the volcanic Tharsis Plateau, searching for potential volcanic shelters, lava tubes, and high-value geologic biomarkers. Utopia Planitia, a historically significant region, Viking II landing site, known to harbor massive underground ice sheets, making it a must-scout for resource mapping. Future Mission Roadmap 2026-2035, NASA's Moon to Mars strategy has reached several critical milestones as of April 2026. Year Mission Milestone Key Objective 2026, Artemis II completion. Record-breaking human flyby, 252,799 miles from Earth, completed April 11, 2026. Escapade twin spacecraft launched to Mars to study solar wind and atmospheric loss. Tuathai 27, Artemis III, crewed Earth orbit mission to test HLS docking. Starship Blue Origin. 2028, Artemis IV, human lunar return, first crewed moon landing since 1972. 2028, Skyfall and SR-1 launch of the first nuclear-powered interplanetary scout mission. 2030s, human Mars arrival, projected time frame for the first human expedition to the Red Planet. Strategic shifts, nuclear pivot. Following the strategic refocusing of the Mars Sample Return Program, NASA has accelerated the SR-1 Freedom Project to prove nuclear electric propulsion can shorten Mars transit times. Lunar training. The moon is now officially the training ground, with the Artemis base camp at the lunar South Pole serving as a test bed for the life support and mining tech needed for Mars survival. Volchaepie crew health and performance exploration analog missions are currently NASA's most rigorous tests for the biological and technical systems needed to survive on Mars. As of April 2026, the second crew, led by Commander Ross Elder, is currently halfway through their 378-day isolation inside the Mars Dune Alpha habitat at Johnson Space Center, habitat life support architecture. The 2700 square foot habitat was 3D printed using lavacrete, a specialized concrete designed to simulate the kind of robust structures that could be built on Mars using local dirt, regolith. Zoned environment. The interior is strictly divided into wet, lab, kitchen, bathrooms, and dry bedrooms, workstations, zones. This concentration of plumbing and mechanical units is a direct test of resource efficiency for future missions. Atmospheric maintenance. While the Earth-based analog doesn't simulate Martian low pressure, the crew is testing advanced potable water dispensers and medical diagnostic hardware designed for deep space self-reliance. Radiation and environment simulation. While it cannot simulate Mars gravity or radiation, the crew must manage high-stress equipment failures and resource limitations that force them to decide between repairing a system or conserving supplies. Advanced food and waste systems. Living on Mars means no grocery deliveries. Chapier is a primary testbed for NASA's Human Research Program to solve the menu fatigue and nutritional decay of long-term travel. The Crop Growth Station. The crew manages an indoor gardening system similar to high-tech home hydroponics. They are currently harvesting leafy crops, herbs, and small fruits like tomatoes to supplement their shelf-stable, freeze-dried meals. Trash to Gas, TTG, technology. In a major 2026 update, NASA is using waste from Chapeya to test rapid composting systems. This technology processes mission waste and inedible biomass into solid products that can be used as nutrient-rich fertilizer for growing future Martian crops. Nutritional monitoring. Scientists are tracking the crew's dietary intake and body mass in real time to determine exactly how much food must be pre-shipped to Mars years before a human crew arrives. The 22-minute challenge. Perhaps the most critical life support being tested is psychological. Communication lag. The crew operates with a 15 to 22-minute delay each way. This forces the team to be entirely independent. If a life support alarm goes off, they cannot wait 44 minutes for mission control to tell them how to fix it. Mental health monitoring. Researchers are using this delay to study how isolation impacts decision-making, mood, and team dynamics, which will inform how NASA selects and trains the first real Mars-bound astronauts. The Chapea Mission 2 crew is scheduled to return to Earth, exit the habitat on October 31st, 2026. In the current Chapea Mission 2, which began October 19th, 2025, the crew is testing their ability to handle high-stress medical events under a 22-minute communication delay. Because real-time guidance from Earth is impossible, the crew's medical officer, Ellen Ellis, must rely on onboard resources and independent decision-making. Recent and ongoing medical simulations 2026. While NASA keeps some specific scenarios secret to maintain stress realism for the crew, several key emergency protocols are being tested during this mission. Acute cardiovascular event simulation. In early 2026, the crew conducted a high-stakes simulation of a cerebrovascular accident, stroke. The exercise tested the team's coordination and their use of the AI-based medical assistant to perform diagnostics without immediate mission control input. Just-in-time surgical training. The crew is utilizing VR/AR modules for high-acuity, low-frequency scenarios such as emergency appendectomies or suturing deep wounds. These tools provide stepwise guidance when the medical officer needs to perform a procedure they haven't done in years. Behavioral health crises. A major focus for 2026 is psychological life support. The crew simulates dealing with the mental strain of long-term isolation, specifically how to maintain group cohesion when someone is experiencing severe stress or menu fatigue from a year of rehydrated food. Equipment failure. During care, simulations often include a double crisis, for example, treating a simulated injury while the habitat's water filtration system or oxygen scrubber simultaneously fails, forcing the crew to prioritize life-saving care over habitat repair. Specialized medical tech in the habitat. The Mars Dune Alpha habitat is equipped with Earth-independent medical operations, EIMO hardware, AI diagnostic platforms, compact rugged ultrasound units paired with AI to help non-experts interpret scans, telesurgical protocols, step-by-step digital decision trees that help the crew transition from non-operative care to emergency surgery if a condition worsens. Advanced water filtration, a critical system being tested in 2026 to ensure the crew has the sterile water needed for medical emergencies. The current crew, Commander Ross Elder, Medical Officer Ellen Ellis, Science Officer Matthew Montgomery, and Flight Engineer James Spicer, is scheduled to exit the habitat on October 31st, 2026.